Okay, no, stop. Okay, try that again. Okay, you should see my PowerPoint slide now. Is that coming in?
Yeah, we see your screen.
Excellent. Okay. Now, I did this yesterday and tried to do it in presentation mode. And for whatever reason, people could not see past the first slide. So I think for all intents and purposes, I'm just going to leave it like this. Okay, so thank you for attending. My name is Michael Strong. I've been with MG Chemicals for 11 years, and I am the R&D manager here. And today we are going to have our first session of what I believe is 5 training sessions within the next few weeks for the product line here at MG Chemicals. Now, I'll apologize right off the bat. As you can tell, my voice is a little broken, a little croaky today. So I'm not as charismatic and charming as I usually am, but hopefully the content will sort of enthrall you enough and you can there's takeaways and stuff for you to learn. So this presentation is going to be about 15 to 20 minutes. I usually like to keep these pretty short and succinct, just in terms of attention span and not overwhelming the audience with too much information at once. I will advise, though, that the website is an excellent source of additional information. If you want to look into things further, there's a lot of good, whether it's written content, video content. It's a great place to learn about our products. Okay, so let's kick things off. If we look at today's agenda. So to start, we're just going to do a basic overview of conformal coating function. I don't know necessarily the knowledge of the audience as a whole, so I'm just going to start off with the basics. If it's redundant, then so be it, but just want to establish a baseline. From there, I'm going to review the conformal coating standards, and these are typically the ones that apply mostly to North America. Now, I'm sure there is other regions internationally where these are very much called upon. But for us, we focus mainly on North American conformal coating standards. So I'm going to review them, what's entailed, and then we'll look at the different coatings that we have that meet these different standards. From there, we're going to look at the different conformal coating types, and that is, again, within the MG Chemicals portfolio line. So these are conformal coating types that we sell. Next, I'm going to look at understanding the specifications for conformal coatings. So we're just going to go and review some of the basic points on a technical data sheet, and I'm going to walk you through basically what they mean. With conformal coatings, it's kind of trivial actually, but I still want you to have an understanding of what these mean because it does come up from time to time. From there, we'll look at how to choose the correct conformal coating, and that's based on some basic inputs and criteria on how you can go selecting. So normally, if you're having a good dialogue with your customer, you should be able to sort of condense it down to maybe 1 or 2 viable options. And then from there, they can do their own internal testing validation to see if that conformal coating will work. Finally, to wrap things up, I'm going to look at some common applications and then just a quick summary. Okay, so what is the basic need for conformal coating? Well, these conformal coatings are flexible top coats. They are clear. They contain a UV tracer, and that is for inspection purposes. So under a black lamp, they tend to give off this bluish hue. So you can tell where you've coated and where you haven't coated. It's also a good way to tell if you need to strip a coating off and rework it, whether you've done it completely and you've removed all the coating. Basically, these things are environmental protection barriers, okay? So they protect from moisture, dust, fungus. Some of them will protect from solvent and corrosive agents, but not all of them. And the other thing is that these are dielectric coatings. They're electrical insulators. So what this permits is that circuit fabricators can now put electrical traces closer together. And these dielectric barriers prevent risk of arcing or corona discharge. Now, if we look at the different standards, the one I'm going to start with is the IPC CC 830 standard, or the Institute for Printed Circuits. Now, this standard was adopted from what was a military standard. That's the MIL I 46058C. Okay, and it came into effect in 1998. And what that means is that MG Chemicals does not have a conformal coating that complies to the MIL I 46058C standard. And that's simply because it's retired and we did not have a conformal coating prior to 1998. So this is a civilian standard that has taken over that MIL standard. And what it does is it establishes a baseline or a threshold for performance. So mostly these are pass-fail tests. It's not necessarily that you can gauge if one coating is better than the other. It's simply it passes or it does not pass. Okay. And what it's testing for is a range of different stresses, whether that's fungus exposure, moisture protection, thermal shock, hydrolytic aging, flammability. And it basically gauges the coating's ability to withstand a minimum dielectric protection after these stresses have been applied. We are currently in revision C of this standard. We do, however, have some coatings that were certified to revision B. And one of the differences is illustrated in this coupon here, which is a standard coupon they use to validate your dielectric insulation resistance. And so with revision C, they've simply expanded the trace capacity. So it is, in fact, a slightly easier standard now to comply to versus the B revision. The next one that is important is the UL 746E standard. And this one gets a little complicated just in the way that it's set up because there's multiple different coating types that you can qualify to. First is a conformal coating, but then they also have permanent and resist coatings. So what is the difference? Well, a permanent or a resist coating, to qualify, you simply have to submit you have to qualify to the UL 94 standard, which is a standard that gauges the flammability of your coating. So if you pass that test and apply simply for a permanent or resist coating qualification, you will obtain that. If you, however, want to qualify your coating as a conformal coating under the UL 746E standard, you have to do the flammability test strip test alongside a series of dielectric tests. And the dielectric tests are very much like the ones from the IPC, but they're a lot more difficult to pass. And what it is that your coating is applied onto a coupon at a given thickness, and it's subjected to a bunch of different stresses. So they look at thermal cycling, temperature aging. Sorry, I think someone's got a hot mic. So anyways, as I was saying, it's exposed to different stresses. There's temperature aging, hydrolytic stability, thermal cycling. And then what you're doing is you're gauging whether the dielectric performance of your coating is in any way compromised after that stress. And they do that by simply blasting it with 6,000 volts to see if the coating can withstand that. Okay, so that alongside the flammability, if you pass, you do qualify as a conformal coating. So if we now pull up our UL page for MG Chemicals, you'll see that we do in fact have coatings qualified to all three different designations. So the 419E is an acrylic conformal coating that's qualified as a conformal coating. 4200 UV is a UV curable coating, and the 223F is a one-part polyurethane conformal coating. So these are the three options we have that are qualified to the UL standard as conformal coatings. We do have some permanent coatings, but of note is the 419D, which is sitting there in the middle, as that is our only active product within those three. The other two we have basically discontinued. And then if you look at the resist coatings, again, the bottom two, 422B and 422C, are still active products. The 422 and the 422A are no longer available. Okay, so now let's look at the different conformal coating types that we do sell. So we'll start with acrylic conformal coatings. And acrylics are amongst the most popular conformal coating type. And that's because they're very easy to use, but they're also very easy to rework. So you simply can strip them off with common solvents and rework the area and reapply it. Okay. First one is the 419D. This is UL certified as a permanent conformal coating. We saw that on the last slide. It's also qualified to the IPC standard under revision B. Chemical resistance is poor, and that is true with basically any thermoplastic material. Their chemical resistance just isn't going to hold up, and it's going to quickly basically dissolve. So that is a consideration. The environmental exposure for these coatings is very important to note. Next, we have the 419E. And again, the great thing about acrylics is that they can air dry, so they don't require any intensive capital equipment. They don't require ovens, but as with almost any conformal coating type, you can speed up the cure with heat. This is a UL certified as a conformal coating. It is qualified to revision C of the IPC standard. And on the bottom there, we have the different packaging sizes available. So you'll see that, in fact, both coatings are available in both liquid and aerosol. And then we've also introduced these touch-up pens for little tiny repairs where you may not warrant a full bottle, but just a small spot repair. So on the 419E, we do carry that in a convenient pen. Next, we have the 4223F, which is a one-part polyurethane conformal coating. So compared to the acrylic, this is a lot more durable. It's got better chemical resistance, but it's also got better abrasion resistance. If there's the possibility of any kind of friction or contact with the coating surface, this will hold up better than will acrylic. Now, the issue with this one is that it requires an oven bake. It's a very aggressive bake cycle. So that has to be, considered at the outset if this coating is going to be a candidate material, given the intense curing conditions in which you need to cure this material. It is UL certified again as a conformal coating, and it is certified on the IPC standard as revision B. Another thing is that we've actually done extended testing with this for both salt fog and sulfur, and that's the flowers of sulfur test. We had customers a few years back that had asked for this, so we did in fact submit the testing. So that is available, and if it comes up, we have actual test documentation to validate that it has good resistance against both salt fog and sulfur exposure. Now this coating line sets us apart from most of our competitors. We really haven't seen too many direct crosses, and that is the idea of a silicone acrylic conformal coating. So what we've done here is we blended two different chemistries to try to get the best of both worlds. So with silicone, you tend to get better flexibility, but also better temperature resistance, whereas acrylics have the ease of rework and they're good film forming and conformal materials. So we have two coatings in this respect, the 422B and the 422C. These are both qualified as RESIS coatings under the UL certification, but unfortunately, it cannot pass the IPC standard, and I think that is because of the silicone content and the moisture testing. We tend not to do so well in that, so we have not been able to pass the IPC standard, unfortunately. But again, this is one of our more popular conformal coating lines. So this is a thermoplastic material. So again, the chemical resistance is poor, but it has superior temperature resistance. So we have a lot of feedback from people using these to coat the different circuits on their drones. And again, you'll see lots of videos, in fact, on YouTube, people testing our material out, and it holds up pretty well. So very popular brand for us. Moving on, we have epoxy conformal coating, and epoxies are just tough, durable materials. So the application kind of demands something that can withstand a particularly harsh environment. Okay. These are oven bake, although the cure cycle is not as aggressive as a polyurethane. It is not UL certified, but we do have it IPC certified under the latest revision B. Again, chemical resistance excellent, as it is a thermoset material. But it is a bit cumbersome in terms of use, because again, this is a two-part system. So you've got to measure out the components, you've got to mix it, and then you've got this concept of a pot life, where you've got only so much time in which you've got to use up the material before it starts to cure. So given that, again, it sort of demands that extended chemical protection afforded by epoxy in order to really recommend it. Last, we'll look at the UV conformal coatings. And for that, we have just one product, the 4200 UV. Now, this does not cure either at ambient temperature or with heat. It cures with UV exposure. Now, I made a mistake actually just now because there is a secondary moisture cure mechanism. So that is for the shadowed areas where you may not get direct light exposure. There is a secondary cure mechanism where over time it will react with the moisture in the atmosphere. And that usually takes about a day, and you'll have everything else cured. So it will no longer be tacky. That is qualified as a conformal coating per the UL standard, as well as it's qualified to the IPC standard in the latest revision C. It is highly cross-linked, so it has excellent chemical resistance. And its feature is the high throughput. Okay, so if time is money, you really got to consider UV because you're curing boards in seconds versus hours. So it's that demand for high throughput that really drives the need for UV conformal coating. Now, I had prepared slides for insulation coatings, but for whatever reason, they didn't save, so I'll have to go kind of off the slides. But I did want to also introduce these ideas of insulation coatings. Okay, and we kind of lump those in with conformal coatings. They could, in fact, be used as conformal coatings, but they have superior dielectric protection over conventional conformal coatings, meaning they have a better ability to insulate against electric discharge. And so for that, we have four products, the 4226, the 4226A, 4228, and 4228A. So if we divide them into two groups, the 4226 and the 4226A are clear coats, whereas the 4228 and the 4228A are red. And we started with the 4228 as a cross for a product called Gliptol, which some of you may be familiar with. This is a product that essentially was introduced in the market in the 1960s. And these coatings are applied typically directly to things like motor coils, windings, copper coils, anywhere where there's a potential for a high voltage discharge. These insulating coatings are used to sort of protect against that. My apologies, the slides didn't save for whatever reason. So there is more information. If you go to our website, we have excellent write-ups on insulation coatings, but I just wanted to introduce that concept today. And now some of the specifications. With conformal coatings, it's really hard to judge if a coating is better than a competitor coating on paper, because a lot of them kind of line up very similarly. They're qualified to the same standards. So it really comes down to customer validation to say that one coating did outperform. We could say that our coating has, good thermal cycling capabilities, but that may be a thermal cycle that we ran that's a little different from what the customer is looking for. So in that situation, they would have to validate it themselves, but we could certainly make a recommendation based on their requirements. I just want to go through some of the specifications so we understand what they mean exactly if they get asked. So first thing I want to talk about is the recoat time, and that discusses the different parameters for processing. Okay. So that is defined as the minimum time required for the coating to sufficiently dry before you can apply an additional coat. So we look at things like if it causes hazing, or if it in fact causes what's called solvent entrapment. And that's where the surface of the coating dries before the bulk of the vapors have got out. And you can sort of entrap solvents that way, and then you have issues with the coating being tacky and not curing in time. So recoat, that's what recoat time is. Dry time to handle is basically the minimum time before you can handle a part without leaving any kind of attack or a permanent impression. Sometimes this is known as tack-free time, but we list it as dry time to handle. Dielectric strength is the maximum amount of voltage before a coating breaks down, and it's standardized to a common thickness. So it's a very actually trivial metric to track because it can be kind of manipulated based on how you do the test. So I can get a better result, for example, if I use a smaller probe versus someone else, or if I'm able to apply the coating much thinner than my competitor, I can get a higher dielectric strength value. It doesn't typically come up too often though. Usually with conformal coatings, you're in the range of about 1,000 to 1,500 volts per mil. It can be a bit of a sticking point with some customers, so you may have to step in and try and teach them the nuances of this test and how it's not necessarily taken as gospel, but it doesn't come up all that often. Dielectric withstand voltage is basically a pass-fail test. So we take the coupon that I showed earlier for the IPC test, coat it, and then you subject it to 1,500 volts ramped at a given rate for 1 minute. If it can withstand without shorting, then it passes, and the result is simply it's greater than 1,500 volts. Glass transition temperature is actually pretty misunderstood because people think it's an upper operating temperature, and it's not. So the glass transition temperature is the temperature at which a polymer material starts to transition from a hard, sort of glassy state into a more flexible rubbery state. But that does not mean beyond the glass transition temperature, your coating fails. And a good example of that is silicones. So silicones are typically operating, if even we look at home construction silicones, they're operating at room temperature, but the glass transition temperature of a typical silicone is about minus 60 degrees Celsius. So it does not indicate failure beyond that. It's simply, yes, your properties are compromised, and it can be a consideration, but it's not absolute. And the last thing I want to talk about is this concept of coefficient of thermal expansion. We report it as a CTE, and that is just the rate at which a material expands relative to its initial state or size at a consistent pressure. And that's actually how you can detect these glass transition temperatures, because below your TG, your material is very stiff, so it's able to resist changes in pressure it's able to resist changes with respect to an external pressure. Whereas beyond the TG, now you have this softening, so it tends to expand a lot more. Okay, so given that, how do we choose the right coating material? And I've broken this down into 3 main considerations, okay? So the first is certifications. Are there certifications that the customer is demanding? In which case, do we have coating that meets those standards? And as you can see, we have several coatings that meet whether it's the IPC or the UL standard. So we're probably covered in that respect, but that should be fleshed out, initially in terms of, do you need qualified to a particular standard or not? When we talk about processing app capabilities, we're looking at a couple different things. So what is the application technique that they're going to be using? Is it going to be dip? Is it going to be brush, aerosol? Do they require something that's in an aerosol can, or are they going to use a liquid? And what about curing? Are they able to use ovens, or in the case of UV, do they have the necessary equipment to facilitate using that coating, or are they simply going to have to air dry it? And then the final thing is the external environment, okay? Because you can't just broad stroke and say this coating will hold up to everything. That's not the case. So you need to know the specifics of the different environmental stresses that the coating needs to withstand in order to operate properly. So for example, if it's exposed to UV light, you want to use something that's not aromatic, meaning you want to use an aliphatic compound like an acrylic or a silicone, whereas an epoxy, UV, polyurethane, they will tend to yellow over time and not hold up so well. Solvent vapors, you have to basically use thermal set materials like your UV and epoxy. As I said before, the acrylics and the silicones, they don't really hold up that well when it's exposed to solvent. And then humidity, that kind of just rules out silicone. They're excellent for moisture, but they don't hold up well to humidity. So it's a bit odd in that respect, but that's just something to consider, is that if there's a high humidity environment, you want to use, typically an acrylic, it tends to do the best, but as long as it's not silicone, that tends to be the recipe for success. So now into more of the sales and marketing side of things. Okay. So if we look at distribution of who our customers are, we have a small sliver there representing the automotive, but that could be a little distorted because I put the tier 1 and tier 2 fabricators, and amongst those could very well be a lot of automotive applications. So it's a little difficult for us to say necessarily when you're dealing with the tier 1 and tier 2 suppliers, what exactly who they're supplying into. Another big one is the aerospace and telecommunications. So that's just sort of a standalone slide, but basically you're dealing mostly with the tier 1 and tier 2 suppliers. Okay, so finally some common applications. With the 422B and 422C, those are the silicone acrylic conformal coatings, and those are very popular with the DIYers in terms of drones. So that what they'll do is they'll coat various circuits within their drones, but also the controllers themselves, the cameras, speed controllers. And it just seems to provide excellent protection against things like dew, rain, snow, splashing, things like that. So we do have quite a bit of a reputation amongst the DIY community for our silicone acrylic conformal coatings. White goods is another one. So things like high voltage relays, because again, that dielectric protection is very important. So used a lot in white goods. And because white goods are used in a very controlled environment, they tend to use simply use coatings like acrylics. So the 419D and 419E, for example, are pretty popular use in white goods. When you're dealing with more of a harsh environment, such as these sump pump switches, you want to have something a bit more durable like the 4223F. So we've had customers using our 4223F for the switches in sump pumps. And our coatings have also been used now in the EV battery world in terms of coating things like bus bars and cold plates. And this not only prevents corrosion, but there is the risk of electrical discharge. And what that does is that creates a lot of heat, and these batteries are prone to runaway heat. So they'll apply insulative coatings on here to sort of help prevent that. Thermoplastic conformal coatings with low dielectric constants like acrylics and silicones are used for satellite protection. And I mentioned low dielectric because what that does is that does not attenuate incoming signals. So for satellite that has to pick up and relay signals, you do not want that signal in any way attenuated. And so these low dielectric materials are good with that. So very good external protection while not impeding the actual signal itself. And then again, we see thermoplastic materials like our acrylic and silicone acrylic coatings used in car interiors where the environment is a lot more controlled than with the outside. So that can be the HVAC control, air actuation, anti-braking systems, things like that. Whereas UV and epoxy tend to be more components under the hood of the car where you could be exposed to road salts, fuel vapors, things like that. And then lastly, we're involved in the lighting industry. So as a protective coating over the dome of LEDs, okay? But a special consideration here is that we put these UV tracers in our conformal coatings. And what that does is that inhibits light output below about 405 nanometers. So we need to pay attention to what the light output of the LED is before we can offer something, or we can do something custom and just not put a UV indicator in. Okay, so now to summarize, MG Chemicals has an expansive line of conformal coatings that adhere to the major conformal coating standard, that being the UL and IPC standard. These include acrylics, polyurethane, silicone acrylics, epoxy, and UV curable. And as well, there was that mention of the insulation coatings, which is a little outside a typical conformal coating use. That's again for high voltage, coating high voltage devices. All our coatings contain thorough and comprehensive technical data summaries that include pertinent data like dry time and dry time to handle, glass transition, coefficient of thermal expansion, and various dielectric properties. Although that's not exhaustive because we've made an effort to sort of truncate and shorten down our technical data sheet. So if there is additional requests that data may be available, just ask. In terms of selecting the correct coating, that will depend on the customer's requirements, namely whether they require certain standards, processing considerations, and the external environment that the coating is expected to hold up to. And lastly, MG Chemicals conformal coatings are used across many industries, including the automotive, aerospace, consumer appliances, industrial equipment, industrial lighting, and the hobbyist market. And with that, I think we want to do a question and answer. Yes?
Yep, I think that would be a good idea, Michael.
Okay, so are there any questions or?
I have a question. I'm happy to go first.
Sure.
So with conformal coatings, you haven't mentioned thickness. I'm assuming that the standard sort of 25 to 75 dry film thickness is what we're aiming for across your different chemistry types.
Across the different chemistry types, yes. But with silicone, for whatever reason, they've upped it to 3 to 8 mil. And I think they did that because some of the coatings are 100% solids. Okay. But yeah, typically with your IPC standard, the adoption is 1 to 3 mil dry film thickness, correct?
Okay, and how does that stand for insulation coatings?
Insulation coatings, again, you typically need about 1 to 2 mils, but there is no external standard for dry film thickness. So it's very consistent with conformal coatings, 1 to 2 mils, good overall coverage, and you're probably protected up to 5,000, 10,000 volts. So that is sufficient.
Okay, perfect. Thank you.
Hello, I'm Eric. I just wanted to ask if you could provide any references for us from automotive business, or you mentioned some other businesses.
So references in terms of
Who is using your materials, if you can share.
okay, so I'm not exactly prepared for that today. I'd have to sort of pour over point of sales reports.
I can maybe try
in order to
pick that up for you, Michael. Radek, hiya.
Okay, thank you, Robert. Yeah,
that's okay, no problem. Yeah, I mean, obviously, as Michael said, we've got lots of customers using the products in automotive applications, globally. It's always very difficult to share company names due to NDAs. So yeah, difficult to do that, but I'm sure we can help offline. But you know what we have. Difficult to publish a list because obviously that's not something that we can do.
Okay, got another question. Are you somehow tested your materials or coatings on corrosive gases?
So the only corrosive gases we have tested is the sulfur, which I mentioned for the 4223F, and that is the flowers of sulfur test. We have tested that coating as well against salt fog, which is just a moisture test. But there are different in terms of like the, I think it's called the ATEX standard test. No, we haven't done anything like that. We just haven't got the request for it. But, you know, if there is an opportunity, we could certainly look at that.
Okay, and I hope it's going to be last question. What wavelength are you using for the curing of the UV cure coating?
So the UV cure coating is actually a broadband. So that is UVA and UVB, typically within about 300 to 500 nanometers. You can use lower wavelength, but it's not an LED system, meaning you have to use a broadband light source. So typically just a simple mercury arc bulb will cure the coating within a few seconds, depending on the irradiance. That'll vary your dose, but that information also is provided in the technical data sheet. But that again, that is not an LED source.
Okay, because we work more and more
coating.
with
So we have had customers.
We work more and more with LED resources because they are more flexible in use. And just wanted to know what.
Yeah, so we are looking to basically adapt our current conformal coating to a UV cure system, which I don't think will be too hard of a switchover actually. So
you mean LED system, right? Because you said you're adapting it to UV, but yeah, so we're working on a formula to adapt the current formulation to LED system, LED cure system.
Okay, folks, thanks. Cheers.
Radek, sorry, can I ask you a question? You mentioned about the gas. This is for the automotive industry, I'm assuming.
Not really. We have some customers who are working in the distribution of gases, and they are using coating. So this is like natural gas and all these things. And there are a couple of things containing sulfur, and at the moment these people are potting these things. And but the end user are thinking to go towards the coating because it's going to be lighter, more easier to repair.
Yeah. So my experience, I've done some work on this on coatings, and as you say, it's always a sort of a balance between doing a coating or a thin encapsulation. So you're using a thinner potting material.
Yes.
What I've seen from some of the, how can I put it politely, the German OEMs for PCBs, they triple coat sometimes with conformal coatings just to try to pass these tests. So what they'll do is they'll put triple the layer thickness just using a conformal coating, I think purely because they have the equipment and they have the material already. So that's normally how they get around surviving these gas tests. I don't know if that helps at all.
Well, some of the coatings are somehow permeable, so it's not really helping to do this sulfur to go through this and so.
Yeah, I know this with the silicones. Yeah, I've seen this all over the silicones, but I know some of the polyurethanes, they are doing double or triple coating to so really what they're doing is they're adding like an encapsulation. So
yeah, but with your PU as it requires quite intensive heat curing, then I was just wondering if your epoxy, because we are not working much with epoxy as a coating, if there is some trace of success, what we could eventually do.
Yeah. Thank you.
Okay, so is there any other questions or? Okay, I don't see anything. Now, I was able to record that, so I should be able to probably have to share a link or something with you rather than send it over email. I think the file might be too big.
Mike, I think after you stop the recording, I think the recording will be available immediately. Yeah, and it will be available to everyone who attended the meeting automatically, if I'm not mistaken.
Okay.
But
Okay. Well, if not, let us know, but hopefully that's the case and you have this recording available.
so now that we have everyone on the calls, as you saw the meeting invite, the next one would be on February 23rd, and it's going to be on podding and encapsulation. So
Okay, thank you everyone for your attention, and we will see you in 2 weeks.
thank you, Michael.
Very much then.
Thank you, Michael.
Thank you. Bye-bye.
Thanks,
Thank you.
Michael.
Okay, cheers, folks.
Thank you. Bye bye.
Thank you.
Nice weekend.
Nice weekend.
Thank you.
Thank you. Bye. Nice weekend.
Bye.
Thank you.
Thank you.
Bye.
Nice weekend.
Thank you. Bye bye.